This is geometry, working on the Unit 8 review. Here's a little formula that we have for hypotenuse equals leg squared plus leg squared. That'll help us calculate using Pythagorean theorem. So we have a leg, which is perpendicular to a leg, and of course the hypotenuse. So we're going to be able to say the hypotenuse is 24 squared, 22 squared, plus a squared. We get 576 equals 22 squared. 24 squared is 576. 22 squared is 484. And we don't know what that extra leg is. So we're going to subtract the 484 across. So take our 576 and subtract our 484. We get 92. That is our a squared. And when we take the square root of that, a is going to be the square root of 92. Now, when we think about reducing, we want to see if perfect squares like 4, 9, 16, 25, 36, 49, do those numbers go into 92. Okay, it's an even number, so a number like 4 might go into that. So we can divide that by 4, and we see that it goes in there 23 times. So the square root of 4 times 23, that's going to give us the answer of 2 root 23. That's actually the leg. 2 root 23. That would be our answer using Pythagorean theorem. Now this time, it's the hypotenuse we don't have. So we need to put our unknown in the hypotenuse spot and put our knowledge, or put our what we know about, our given, which are both legs, in the leg spot. So that's 36 plus 81. 8, 9, 10, 11, that's 110, plus 7 more is 117, and we take the square root of that. Now I see that 117, a 7 and a 1 and a 1, that adds up to 9. I know 3 goes into 9. So 117 can be divided by 3. Which can also be divided by 3. So we have a pair of the same numbers. So in other words, 117 is divided by 9. So AB is 9 times 13, which is 3 root 13. We know we need to leave it in radical form, so we wanted to simplify our radicals, no decimals. For this next one, we know that we have a side that's 14 and 2 of them that are 25. I broke it into a smaller triangle that has an altitude that comes down, a right angle. Now we can use Pythagorean theorem. We have hypotenuse squared equals leg squared plus leg squared. 625 equals 49 plus h squared. You might realize that this is a Pythagorean triple. That's the word I was looking for. Pythagorean triple. That there's a pattern of 7, 24, 25. It can be a shortcut, but that could be a tough one if you don't know that one. So you know you're missing height is 24. That's up and down. So your area, your height is 24. Your area is going to be half of the base, which is 14, and the height, which is 24. You can take half of either one of those. It doesn't matter. Or you can just say 14 times 24 divided by 2, and we took half of it. 168, and those are inches squared, square inches. We have a ladder up against the wall. The ladder is 25.5. The height is 24.1. Now this clearly is not a Pythagorean triple because they have decimals already. Pythagorean triples are numbers that are whole numbers that make Pythagorean theorem work. This would be 25.5 squared equals x squared plus 24.1 squared. And using a calculator, it's not that big of a deal. 650.25, 24.1 times itself is going to be 580.81. 580.81, and we subtract this 580.81. So 650.25 minus our previous number gives us 6944. That's what x squared equals. Well, I know that 8 times 8 equals 64, so this is going to be a little bit more than 64. Well, a little bit more than 8 because 8 times 8 is 64. So a little bit more than 8. And there we have it. It says to round it to 1 decimal spot. So x is going to equal 8.3 feet. Here we're taking a boat. We're going to go around this reef. So we're going to go to the east 15 miles. We're going to go south 30 miles to get past this shallow reef. How long did it take? What's the distance to just go straight across? How much extra are we doing? So we see that we're doing 15 plus 30, but we have to do Pythagorean theorem. Are you realizing what questions are Pythagorean theorem? So 200 and 900 is 11 plus the extra 25. We take the square root of that. Now I see that it ends in 25. Now they say give your answer to the nearest tenth. So actually we don't have to divide that up, which this could give us some 9 times 5 times 25. We know the square root of 9. We know the square root of 25. That is still this 1125. So you could say 15 times 5. 15 root 5. But they ask for a decimal. So the square root of our 1125 is 33.5. Since this went 45 minus 33.5, we're going an extra 11.5 miles. We'll round that up to 11.5 miles extra. Here we're deciding which type of triangle we have, right, acute, or obtuse. I have our little formulas right across the top of our page. Okay, it's just Pythagorean theorem that if it's equal, that makes a right triangle. So we're going to take our largest number as C. We're going to compare it, so I like to use a circle. Okay, I don't think there's a Pythagorean triple that we're going to use with these numbers, so I don't expect this to come out straight. So we have our 676, and we're going to add that to our 121 and our 576. So we're going to take 121 and add that to our 576. We get 697. So we know that 697 is greater. As long as we do this with C being written first, smaller, C squared is less than, this is an acute triangle. We're going to use Pythagorean theorem topic again. We're going to compare it. We're going to put our greater than or less than symbol in there with 20 squared and 48 squared. So 52 squared, 48 squared, and 20 squared gives us all of our numbers. So 2704, comparing that with 400 and 2304. We're going to combine those two to get 2704. That makes 2704, so that means it is perfect and a right triangle because it equaled, it was the same. The largest number is 8. Compare that with 2.4 squared and add that to 5.8 squared. So we're getting 65, 61, 5.76, and 33, 64. And we add this number with that number, we get 39.4. So 65 is much larger than 39.4. So this is clearly an obtuse triangle. This is not just a guessing game to decide what type of triangle we have. We do calculations that follow Pythagorean theorem. If it's greater than, C squared is greater than, it's obtuse, equal to, it's a right, and less than, it's acute triangle. This is a 30, 60, 90 triangle. We have two formulas, and they're written right here for you. I know that we're aware of the short side. We're looking for the long side. So the long side is x. It equals the short side times root 3. That's your answer. X is 5 root 3. Your hypotenuse is going to be 2 times the short leg. So the hypotenuse is double the short leg every time. This time we have a long leg. The short leg times root 3. The long leg is 12. We have to divide the root 3 out. We've done this many times. Now the root 3 is on bottom, so we have to do what's called rationalize. So we multiply by a value of 1. This gives us 12 root 3 over 3, which is 4 root 3. That's the only side they're asking for. If we wanted to know the hypotenuse, we knew that we could double the 8. You don't need to double the 3. That would be the hypotenuse, because the hypotenuse is double the short leg. In a 45, 45, 90 triangle, here's your formula. You need to make yourself familiar with these formulas. We know that the legs are going to be the same length. And we know that the hypotenuse is going to be the leg times root 2. So this is 4 root 2. Okay, this is a little combination of the two. This is a 45, 45, 90 and a 30, 60, 90. We know the hypotenuse, the short leg, is half of that. The long leg is the short leg times root 3. So this length from here to here is 14 root 3. If you want to know what 14 root 3 is, it looks like it's 24/25. If this leg's 14, we know this leg's 14. And of course, this would be 14 root 2. It's the leg times root 2. Well, we're looking for y also. So we need to take our 14 plus our 24.25. You cannot combine these. You can't call it 28 root 3. That doesn't work. But you can call it 38.25. That was y. We have a right triangle. We could talk about SOHCAHTOA. Sine A, that means we're going from the A's point of view. Sine is opposite over hypotenuse, so that's 7/25. Can't be reduced. Cosine is adjacent over hypotenuse, 24/25. And the tangent of A is opposite over adjacent, which is 7/24. If we wanted to calculate the angle of A, we could use any of those. Doesn't matter which one. So we have the cosine of A equals 24/25. We're going to get the measurement of angle A by itself, so we're going to use cosine inverse of 24/25. Get that in here for you. You can see it all calculated out. So we use our calculator. Second cosine of 24/25. You have to use the inverse, cosine inverse. Gives us a 16-degree angle. You need to be sure you're in degree mode. If you're not getting that, you need to be in degree mode. The measure of angle A was 16.26 degrees. Okay, the sine of B, from B's point of view, sine is opposite over hypotenuse, so that's 24/25. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And the value of B, we could recalculate it again, but you can also do 90 minus 16.26. Let's say 90 minus, you could do previous answer, you can just arrow up, that brings it right down, and you get 73/74. That is B. Here we have a triangle up against a building, 150 away. We could make up a fun storyline about this if we needed to. Okay, we're trying to throw a frisbee up there at a 65-degree angle. What's the height are we getting on top of the building? So this is opposite number, or value at least, and this is adjacent. Opposite the angle, adjacent. So we know that that's going to be tangent of the angle. Always tangent of the angle. This is sine of the angle equals a fraction. Cosine of an angle equals a fraction. This is tangent of an angle equals a fraction. Here we didn't know the angles, but we knew both opposite and hypotenuse. Here we know the angle, we just don't know both opposite and adjacent. But I'm going to multiply by the denominator, and I can do that in my calculator. 150 times tangent of 35, I get 105. And those are feet. That is H. Here we're driving up a hill that's 19 kilometers. We have an angle of elevation. It's looking up at the top of the hill, 15 degrees. We're trying to figure out what vertical height has that hill allowed us to go up. So opposite, adjacent, or opposite, this is hypotenuse, of course, because it's across from, this is across from the angle that we were given. So that's the opposite side. And when you're across the 90, that would be always the hypotenuse. So using the concept of SOHCAHTOA, you've got to know this. This helps you determine which trig function to use. We are looking for the opposite. We know the hypotenuse, O and H. That's going to be sine. So we start out with sine, sine of the angle. We know what the angle is. We're not solving for it. We're solving for one of the sides. We multiply by the denominator. So we get 19 sine of 15. So x is going to be 4.92. And those are kilometers, because our units were in kilometers. Here we're solving. There's our triangle. We're looking for side B, side C, and the angle. Well, we can redraw that if we wish. A, B, C. Angle B is across from side B. Angle A is across from side A. And angle C is across from side C. So what we know for sure is that A is 20 degrees and side A is 6.2. So we're going to use some more trigonometry. We cannot use Pythagorean theorem here. We don't have two sides. We can do opposite over hypotenuse. That's the opposite of the angle we know of. So that would be sine of 20 degrees. You always need to put your angle with your trig function. Equals the opposite number over the hypotenuse. This time we have a variable in the hypotenuse. We still multiply by that denominator. That gives us c sine of 20 equaling 6.2. Now we need to get the sine out of there. So we have to divide by the sine of 20 to give us just what c is, because now c is all by itself on top of the fraction. So 6.2 divided by the sine of 20. 1813. You could do Pythagorean theorem now, but let's just keep practicing our trig. Now we need to solve for this adjacent side. Adjacent is going to require an A. There's two different trig functions with A. Since we know the opposite, I can find the adjacent by using tangent. Tangent of 20. The opposite side is 6.2. The adjacent side is the letter B. So I'm going to multiply by the denominator, which is the letter B. I'm going to divide by the tangent of 20 because I want that to leave the B alone. You want the B by itself. So 6.2 divided by the tangent of 20 gives me 1703. And then our angle is going to be complementary with 20. So 90 minus 20 makes 70. This has to be 70. On this side, we know that B is 18, C is 25, we don't know A, and we don't know either angle. The three things we know are the 90, the 18, and the 25. So we could do Pythagorean theorem, which would be 25 squared equals 18 squared plus our unknown squared. Pythagorean theorem, hypotenuse goes first. So that's 625. 18 and 18. I don't want to say it wrong. 324. Always safe to check. So we take our 625 and minus our 324, 301. Well, that's not a perfect square. Okay. We're rounding to the nearest hundredth. It's right there. So we can do decimals here. It doesn't have to be exact. So we get A to be 1735. We round that number up because the third number is 5 or bigger. Now, listen to this carefully. We're solving for an angle. This is 1735. We solved for that one. I want to use these whenever doing calculations if I can. So from A, we're going to use adjacent and hypotenuse. Adjacent means next to. So adjacent and hypotenuse. The trig function we use for that is cosine, adjacent over hypotenuse. So we're going to do cosine of the angle. We don't know the angle, but that's the A. That's where the angle is. That makes 18 be the adjacent side and 25 be the hypotenuse. Now the measure of angle A, get the cosine out of there. Put it to the other side of the equal sign. So that cos -1, that's cosine inverse, of 18 over 25. Well, you can do that in your calculator. You use the second button. And then if you look closely at cosine, it has a cosine -1. It's written in blue. So second cosine gives you a little -1. And the fraction we know of is 18 divided by 25. It's a 43-degree angle. 43.95 degrees. And then if we take 90 and subtract 43.95, we're going to get 46.05. Worked out great. Here we have a straight line. I've squared it off using a right triangle, which makes this a length of 4. 1, 2, 3, 4. That makes that a length of 2. So we can use Pythagorean theorem. AB squared equals 2 squared plus 4 squared. That's 4 plus 16. Don't say 4 times 2. It's 4 times 4. So that's AB squared equals 20. So AB is going to be the square root of 20. And we know that the square root of 20 is made up of 4 times 5. 4 is one of those perfect square numbers. I know the square root of 4. That's 2. And then 5 is still inside the square root. That's the length of AB. Angle of elevation is the angle that you're looking up at B. That's this guy. So we're going to try that again. What trig function uses the opposite and the adjacent? Which trig function here uses the opposite and the adjacent? That's going to be tangent of A equals the opposite side over the adjacent. We have one variable. Tangent of the angle equals a fraction. I'm going to find the measurement of angle A by moving the tangent to the other side. That's tangent inverse. That's when you use inverse, when you get the angle by itself, of 2 over 4. You can call it 1/2 if you want. So tangent inverse of 2 over 4 is 26.57. 26.57 degrees. That's the measurement of angle A. Okay, last one. We have this person looking down at goat number 1. We have this person looking down at goat number 2. It's 34 degrees to look down at this goat. So this is what we have, looking down. So we make this triangle. The person is 48 up. Well, I don't really have a 48 right here. I put my 48 on this side. I need to figure out the total length, horizontal length, because I'm trying to figure out the distance between the goats. So I need to know the long side here, and then the little bit shorter side here, and subtract the two. So this is opposite over adjacent. We're not dealing with the hypotenuse. So again, that's tangent of the angle equals the opposite over the adjacent, we'll call it A, multiplied by the denominator, divide by the tangent of 34. You need to know how to type that in your calculator. 48 divided by the tangent of 34. That length of A is 71.16. Those are feet. 71.16 is the total distance across. Now we have this other triangle that you look down at the goat, but it has a 48-degree angle. 48-degree angle. It's still the same height above, still 48. But it's much shorter. So we're still going to use tangent because that's the opposite over adjacent. We're not using hypotenuse at all. So opposite and adjacent. Got to use 48. The opposite. Oh, it's 48 also, huh? 48 is the angle. 48 is the height. That's funny numbers, but okay. Just doing the math. Then we divide the tangent down. We have B equaling 48 divided by the tangent of 48. Tangent of 48 is not 48. 48 divided by the tangent of 48. It's not 48 divided by 48. You've got to divide it by the tangent of 48. So B is 43.22. So this distance is 43.22. So we have the total distance, not counting this one, or small part plus small part equals the big part. Another way to think about it. We need to take 71 minus our 43. 71.16 minus our 43.22 gives us 27.94 apart. That's how far they are apart, and those are feet. Good luck, everybody.